Hello again, this is part 3 in the series on React file-based routing, static site generation, and server-side rendering. In this part, we'll look at a Next.js app and its approach to static site generation and server-side rendering. So to create an app with Next.js, you can scaffold it with npx create next app. And in this example, we answered as follows. Do you want to use TypeScript? Yes. ESLint? Yes. Tailwind CSS? No thank you. Source directory? Yes. App Router? Yes. App Router is a newer alternative to the Pages router, and it's kind of fundamentally different to the Pages router. They can coexist in a project. Vercel has said that the Pages router is not going away soon. And in fact, some routes can be served by the Pages router and some by the App Router in the same project. We did say yes to customize the import alias, but as you can see, we didn't. We left it as @ /. So that's to do nicer imports without really long .. / referencing a component or a file in your project. And the project was created. The next thing we did is we enabled TurboPack. TurboPack is a new bundler and transpiler that replaces the pre-existing Babel and Webpack tooling. So you're probably aware Babel can do a couple things. In a React project, Babel transpiles JSX into JS, and Babel also transpiles into lower language versions of JS. So it transpiles into the lowest common denominator for the browser. So TurboPack has replaced that in Next project. The motivation being that it's much faster because it's written in a lower level language, Rust. And in version 13 of Next.js, it wasn't really working for our apps because Vercel were still working on things, features in TurboPack. When version 14 of Next came out, it did start to work in our project. So it'll significantly cut down the times when you start the project or when you make a change and it has to recompile a page in order to execute it, to test it, page and all the supporting components. The times shown here are for start and compiling the page of a newly generated app with nothing changed yet. Obviously, those times will vary as the app changes. And that's without any extra data fetching or anything added. It's literally just a generated app. And so let's talk about how file-based routing is handled in Next.js, particularly with the App Router, which does differ from the Pages router. So with the App Router, underneath source, you have the app folder. That is the location of the App Router. Any path that has a page TSX automatically becomes a route. So right under the app folder, if we have page TSX, that becomes / after the host. If we have about us, that becomes host about us. Products, similarly with a page TSX in it, becomes / products. And to talk about the rest of these things, we should talk about dynamic segments. On the right-hand side, this is a screenshot from the Next.js documentation. And dynamic segments are quite handy. And you handle a dynamic segment by creating a folder and putting its name in square brackets. They give the examples of ID or slug. It can be whatever you want it to be. And in our example application, we've created a products hierarchy. So we've got a folder called products, and it'll have categories and product codes underneath that. So routing handles dynamic segments with parameters passed in. And so we'll take a look at that. Let me actually switch over and do a demo of the project. So under the app folder, you'll see there's a products folder. That products folder has a page TSX. And so that automatically becomes / products. So if I go here, if I click on products, you'll see in the URL / products. And on the server side, it's doing some data fetching to find what are the different possible product categories. It's calling a remote REST API to do that. And it comes back, and the possible categories are batteries, cables, charge controllers, and solar panels. If I hover over batteries, you may see at the bottom of my screen, if it shows up in the video, it'll be / products / batteries. When I click on it, it'll certainly show up in the address bar. So here's / products / batteries, and we want to come back with all the products in the specified category, that being batteries. So let's take a look at what's happening in the project to facilitate that. Under products, we've got a folder called category code in square brackets. That has a page TSX in it. Let me open it up. That page TSX has a page component in it. So this is a React component that gets rendered for this page route. This component takes a params object that looks like so. It's going to take a category code as an argument. So that corresponds to the folder name, and whatever gets passed in becomes this argument here. So we'll get the category code, and then what we're going to do is get products in category. So this runs on the server side. So if you are doing server side rendering on the server side, this page component is going to execute. You'll get the category code passed in, and here we'll take that category code, pass it to a utility that does some data fetching for us. So that's just calling a remote REST API. It's another module in this project. And it's going to give us back an array of products where we've got products defined elsewhere. For each product, we'll be showing, we're passing that into a product list component, by the way. And so there's an array of products. So for each product, it'll show the product code and the name and compute a file name for an image. So now if we actually click on one of these, like say we click bat d12080, now our URL becomes /batteries/bat d12080. And it pulls the product code, the product name, and a description. Let's take a look at how it does that. So underneath category code, there's another folder in brackets, in square brackets, called prod code. If we open up prod code and look at, it's also got a page TSX, so that's what's executing. That page component takes a params object with two parameters. It takes the category code, but it also takes a prod code. So the category code being batteries, the prod code being bat d12080. And this time, it's going to request to get the product from the code. So that can make a call to the upstream API and get a response. I should note one thing that Next does is it caches fetches. So and we're using fetch to do it. So they've changed the fetch on the server side such that they've got caching implemented. So if you make a fetch to a specific URL and then you make another fetch to the same URL elsewhere in the project, doesn't have to be in the same place, Next will cache the result and serve the cached result and return the cached result from that fetch call. You can invalidate a route to clear those, but be aware of that. So knowing that it worked that way, we actually designed this to pull the whole list of products. This site doesn't have so many products that we couldn't do that. If you had 600,000 products, you would approach it differently. But if you've got hundreds of products and you're not pulling a massive amount of info just to get a list of them, it's pretty small, then even though we call fetch in this, it doesn't actually make a remote call over and over and over to that REST API every time, because we knew that the cache was implemented, so it could work pretty efficiently. So to render it, we got passed in a category code, a prod code. We say get product from code, and then you'll note that the product details are, here's the category name, and here's the product code and whatnot. So that's coming right out of the product, okay, that we got back from the REST API. So continuing with the discussion, that's how it handles a few things. So we talked about dynamic segments. We've also covered server-side rendering, because all the stuff I just described, that happens on the server, not on the client. So on the server, you've got the credentials to do a fetch from a remote REST API if you set it up thusly, which we did. So the request goes to the server-side code, and that React component does the data fetching to the remote API, gets the results. On the server, that JSX will run, and you'll get back HTML. So you'll get back a populated HTML result that gets sent to the browser. So I want to take a look at that in the browser dev tools and show you that really quick. Sorry, let's talk about dynamic segments and the resulting HTML, and then we're going to look at static site generation. Okay, so if I look at this page and I press F12 and I do a shift reload, oh, forgive me, go to the network tab, there's my document request. If I click the document request, I did not get an empty HTML file with a div ID equals root or something. I got a fully populated HTML file. So it's not going to leave it up to a JavaScript bundle on the client side to rewrite the DOM. This is exactly what came back from the server this way. So that's going to match a lot more closely to the runtime DOM. So if I'm not going to go and expand every element, but if I was to expand the DOM in the page body with the product details, it'll all be in there. Okay, so what we got back from the server is going to be quite close to what we see at runtime. So that's because it's server-side rendered. And we want to talk about file-based routing and static site generation, but to discuss those things, I really have to discuss server-side rendering. Why? Because static site generation, what we're going to do in this app is we're going to statically generate every possible route, which in this case, we're talking about product pages. So we want a different page pre-rendered and generated to HTML files for every one of these products. So to do that, let me show you how Next handles that. In a Next project, when you run a build and static site generations enabled, as I mentioned, for every single route in your project, it'll generate HTML for it and output those as static files that you could upload to a web server. And basically, for each possible route, it needs to know the parameters, which in our case, for this page hierarchy, it's category code and prod code. The question is, well, how would it know what all those possible pages it has to generate are? Well, they allow you to implement a function called generate static params. And what that does is, however you want your logic to work, it returns an array, and that array has a bunch of params objects, each one being the params for one page. So for each one, we're going to generate an object that looks like this. It says prod code is whatever prod code, category code is whatever category code. In this case, we called get product data. That's an array of products. We called map on it. So that's going to return a new array where each element of the new array looks like this. It's prod code colon the prod code, category code colon the category code. And then for each element in that array, it's going to call a page function one time, and it's going to execute that and take its results and generate it as an HTML file. So it's going to have a fully populated HTML file with all the data in it. So the data fetching happened at build time. So this function only runs at build time. And at build time, we call our remote REST API here, and we generate a list of products. And as it runs for each one, it's going to call get product data from code, still at build time. So when this executes, it's going to call the remote REST API, get the information for each product. And let me show you what if I run an npm run build, trust me, I did it not too long ago. This is what it'll look like. I've already run it to save time. You'll get a dist folder. Under products, instead of having the category code and the prod code, now it's already got them populated, right? So there's the actual categories under products: batteries, cables, charge controllers, and solar panels. Under batteries, let's just stay with them. For every product code that got passed as a possible set of params, it's generated a subfolder with that product code and put an index.html file there. That index.html has the data statically generated. So now we can take the contents of dist, take that, put it on a web server, and it's good to go. You no longer need a node interpreter at runtime, nor do you need a connection to that remote REST API. So for things that don't change too frequently, you can statically generate them, and it's extremely useful. In this example, products are not changing by the minute, so it would be extremely useful to statically generate them, and you can't beat the performance of putting those HTML files on a web server. For things that need to change in real time, like say you wanted to show on your product pages that you've got 20 available of a certain product or something like that, you could still do that. And instead of doing server-side rendering, if you put this as static files on a web server, you could always have client-side JS that runs in the browser and makes a remote fetch to a dynamic API on the back end and just pulls a small part of it, like 20 available or something like that. But the other data that got generated at build time is fine. That doesn't change, right? The product code didn't change. The description didn't change. So it's pretty awesome, actually. And for some sites, this is a great alternative. Okay, so we talked about how the build works. And here's a diagram of it. So I'll run through that one more time. So for data fetching, if we have a node interpreter, let's say it's server-side rendered, not static site generation, but just server-side rendered SSR. So the browser makes a request, staying with the same example, /battery/bat d12080. That request goes from browser to web server, which proxies it to the node interpreter. The node interpreter realizes based on the route under the app router that it wants to run this page TSX in /category code /prod code, those being in square brackets. Okay, and it gets the parameters, packages them up, and our code is doing a request to the REST API, the remote REST API. And that remote REST API receives those parameters and gives you back some JSON. This page component will receive that JSON and parse it and then do server-side rendering to render that. And what gets sent back to the client is HTML, not JSON. So we're going to get HTML. The web server, of course, reverse proxies that. So what the browser receives is a fully populated HTML document, which is different than the client-side rendered app, where the browser receives a pretty empty HTML file with placeholders and a big JavaScript bundle, and everything happens by rewriting the DOM at runtime. And for data fetching, you would be doing fetching from the browser to the server, as opposed to from the node interpreter on the server to the remote REST API. Taking a step further to do static site generation, you do the SSR, but you take the results of that SSR and spit it out as HTML files. So hopefully this is quite helpful. And in the next part, we're going to talk about a framework called Vike, and stay tuned for that.